Let's look at one example that has to do with slope. This is probably the toughest ones that students face. When we're looking at this problem, what they're giving us is they're giving us an ordered pair, the 6, 3. Let's go ahead and designate that x1, y1, because we're actually going to use a formula on this one. And they're giving us another ordered pair. Let's call this x2 and y2. And then it tells us the slope. This is where the algebra comes in. This is where the work we've been doing up to this point, connecting all the different chapters, comes into play. Because I could try to draw the picture. I can go 1, 2, 3, 4, 5, 6, 1, 2, 3, and put a point. The problem is, where do I put this other point? That's going to be the big question. What I know is the point has to be somewhere over here. I don't know where it's going to be. So I have a slope of 1/2. Well, in this case, in my opinion, I think the formula actually makes sense to know. Slope is the change of y's over the change of x's. I'm substituting numbers into this formula. So I've already designated which is the first, the x1, y1, which is the x2, y2. I'm just going to substitute numbers into the slope formula where they go. So slope goes in as 1/2. y1 I designated as a 3. y2 I said was a 2. x1 is a 6. And x2 is the variable r. Well, the rules apply here that we've always applied. Simplify if you can. Well, I can make a 3 minus 2 into a 1. Well, maybe that's all I need to see. You can clear fractions if you want to. Your common denominator, I'll show it to you this time, is going to be a 6 minus r over here and a 6 minus r up here. And over here, I'm missing the 2. You notice I put the extra parentheses in there where I needed to. We saw the concept of common denominator in the past. This is the same concept here. So I could get the same common denominator. I could work with 6 minus 2 equals 2 times 1, which is 2, and start solving the equation. That is an option. What do we get? Subtract the 6 from both sides. Negative r is a negative 4. Sign change for slope of, or the r value of 4 with the slope of 1/2. Well, that's one option I have. I've got lots of different options here. Let's not do common denominator. Let's look at what we got in front of us. Because sometimes we just need to simply look. Well, this turned back into the 1 again. So I have 1/2 equals 1 over 6 minus r. Well, honestly, that's not so bad. We already have the numerators that are exactly the same. Look at these denominators. They better be exactly the same as well. How do I solve this? Same thing. Subtract 6 from both sides. Negative 4 is a negative r. Change sign. Still got the r equal to 4. Different way of doing it. Just looking at the equation. Sometimes I can do it, sometimes I can't. A third option I'll throw out there, we haven't done a whole lot of work with it yet this year, is the concept of just simply using cross products. Multiply those two things together. 1 times 6 minus r. Multiply those two pieces together. 2 times 1. Well, if you do the math, I get 6 minus r equals 2 times 1, which is exactly what I had here, which is exactly what I have over here. That's why those practice pieces come into place. That's why equations become so important to us, because we start to see different methods to get the same thing. This is tough for students because we're kind of working backwards through it. Again, if you can go to this picture that's still sitting over here and you can find that ordered pair, we just figured out that r is 4, so the ordered pair is a 4, 2. If you could plot the 4, 2 and say, well, that slope right there is a 1/2, go for it. Sometimes you see it, sometimes you don't. So what you're looking at here on this particular thing is the fact that you got 4 different ways to solve this problem. The thing is, no matter how I'm solving it, I'm still getting the same answer every single time. So we're going to try it again. We have two ordered pairs, P4 and 3, negative 1 with a slope of negative 5/8. Okay, I'm going to choose again to set that equation up because to me that makes the most sense. We have slope, which is defined as the change of y's over the change of x's. I'm going to define this is x1, this is y1, this is x2, this is y2, and I'm going to use that definition with the slope they give me. So negative 5/8, y1, which is a 4, y2, which is a negative 1, x1, which is a p, x2, which is a 3. Automatically, I make that a plus. That becomes a 5. Are these two pieces, the -5 and the +5, exactly the same this time? No. But I've got strategies. I could change them if I want to. I'm going to choose this time to show you the cross products, because that's what I see this time when I do the problem. I'm going to cross these two pieces here. -5 with a p minus 3. I'm going to cross the other two pieces, 8 and 5, which is a 40. I see this is an easier method because I don't want to have to mess around with sign changes. I know cross products. I know if I multiply straight across numerator and denominators, I can get an equation set up. It's also, if you think about it for a second, it's also a concept of common denominators. What's common between this 8 and this p minus 3? Well, the combination of the two. Over here we're missing p minus 3, and on the other side we're missing 8. Look, it's the same thing. Finish solving it. Distributive property. We have that sign change happening. Don't forget that. -5p plus 15 equal to 40. Subtract 15. -5p, 25. Divide by -5. P has to be a -5. See if I'm right. Yep, problem solved.